Welcome to the Athlete Climate Academy, where we engage with athletes, scientists and communicators about the critical conversations that we need to have regarding the climate crisis. And we've got an awesome guest for you today. Marc Oliva holds a PhD in geography from the Universitat de Barcelona, where he now leads a research group focused on Antarctic, Arctic and Alpine environments. His adventures in various mountain regions like the Rocky Mountains, Alps and the Pyrenees have given him a deep understanding of how cold climates shape our planet. And that's exactly what we're going to be asking him about today. Marc, welcome to the pod.
Thank you very much.
So you study permafrost for a living. Can you explain to us what permafrost is and why it's important for us to study it?
Yeah, permafrost is the layer of soil, rock, or sediment that remains frozen for at least 2 consecutive years. And it is mainly found in the polar regions, such as the Arctic or Antarctica, but also at high altitudes. And the active layer of the permafrost, what we call the upper layer of the permafrost, what we call the active layer, thaws in summer and refreezes every winter. And while the deeper layers remain permanently frozen. The fact that these deep layers remain frozen control most of the process that happen in these areas in terms of hydrology, vegetation, the geomorphological process. But it is also crucial for all the equipment, the infrastructure that we have in these regions. When we build in permafrost carriers, we need to consider that the deeper layers are frozen, and that's why understanding and studying the permafrost is crucial in our changing climate. We need to understand and potentially to mitigate the effects of global warming, also to protect the ecosystems and infrastructures. And as climate continues to warm, we need to understand, to do more research on permafrost to predict and to manage its global scale effects.
So when thinking about the cryosphere, the ice around the planet, our minds obviously go straight to things like ice sheets and glaciers. What got you interested in researching permafrost in places like Antarctica and the mountain regions?
Well, I come from the Mediterranean. I'm from Barcelona, from the hot Barcelona, Catalonia. So you usually like these are islands that I do not have. And that's why I was excited. I was attracted by the core processes, and I know this was the reason to go for the cold. And from here, you have 2 options: either you go up to the poles, to the polar regions, or you go up to the mountains. So that's why I decided to go for permafrost research.
But you did also go for the poles as well, and you've done a little bit of work on permafrost in places like Antarctica. What have you discovered? There's big changes happening there all the time. What have you discovered in terms of permafrost and other cryospheric conditions there in Antarctica as they change over time?
Well, I started to study core processes in Antarctica, but my main goal there was not to understand how permafrost changes over time. We're doing this sort of stage in the Pyrenees. In Antarctica, my research basically focused on how glaciers have retreated over the last millennia to see if this is something that is being unprecedented, or if this is kind of the amplified response of climate change in Antarctica, and that we have to be worried about.
And what are the big things that are changing in Antarctica?
So first of all, Antarctica, it's really big. It's almost 25 times the Iberian Peninsula, but most of it is covered by glaciers, but huge and very thick glaciers. So there's a very tiny area. It's almost the size of Catalonia that is ice-free. Only 30,000 square kilometers. It's ice. And in these areas, there is permafrost. But unlike in the Arctic, this permafrost is mostly mineral. It's not. It does not contain organic water, such as in the Arctic. And the organic matter is important. It's important in this climate warming context, because when this frozen air thaws, then all this organic matter can decompose and release greenhouse gases into the atmosphere, mainly the organic CO2 or methane, these gases that contribute to global warming. And these can create a feedback loop and accelerate climate change. In Antarctica, changes in the permafrost can be indicators of global change, but their effects are much more localized than in Europe.
Huh, that's super interesting. So when we lose permafrost in places like Antarctica, because there are no organic matter there, it won't off gas things like methane and carbon dioxide in the same way as the Arctic.
But the thing is that we don't have much vegetation in Antarctica, so that we will not have much organic matter preserved in the permafrost. And on the other hand, we have very little areas where we have permafrost. I mean, there is permafrost beneath the very thick ice sheet, but this is not like in the Arctic, where 25% of the northern hemisphere surface is underlined by permafrost.
Wow. So the big changes in Antarctica are obviously the glaciers, the ice sheets that are disappearing faster than we would like going forward. But when they do finally go, places that have ice sheets sat on land, and there's a lot of land underneath Antarctica, it's one of the, it's a huge continent. That's when the glaciers melt, when the ice sheets melt into the water, that's when we're going to see sea level rise. So when we think about how Antarctica is going to affect the rest of the world, it's actually in sea level rise, it's actually in the salinity of the water, it's actually in global ocean currents and things like that. It's going to have a huge effect, right?
Yes, it is. I mean, Antarctica stores ice as much as, I think, 6 meters of sea level equivalent. So if all Antarctica melts, the sea level will increase by approximately 6 meters. But this will not happen. We will not see. So we have to be, let's say, less catastrophic than some of these that we read in some newspapers or some organizations. But that's the process is that when Antarctica, part of Antarctica collapses and melts, then we are introducing fresh water into the ocean, and then we are accelerating all the connection between the oceans and the atmosphere, and this is translated into the rest of the world.
As a climate advocate and someone who teaches climate science and things like that, I don't really want to see much of the ice disappear on Antarctica. But as a geologist, that's my kind of like my background, I'm really curious to see what's happening underneath the ice in Antarctica. Like, it's going to be a new kind of land that we've never really seen before, and I'm excited to see what it's like down there.
Yeah, I mean, now we have some ideas of what's beneath the ice sheet. For example, we know that there are hundreds of lakes in Antarctica, and some of the lakes are really, really big. And they have been already treated, such as the Oslo Lake, that was just below 3,000 meters below the Russian station. So we know how the ice drains. We know how is the subglacial topography, but we don't matter the other processes. Is there a permafrost in some areas just in contact with the surface or not? I mean, we know that in some areas there is permafrost, but in others there is not. And for example, this is one of the things that we are seeing in some areas when the glaciers retreat, then the permafrost is exposed. And in other areas when permafrost when the glaciers retreat, then permafrost starts degrading. Forms after following this glacial disappearance. So the system is not that easy. It's not so straightforward to say, okay, then the temperature is increased, then permafrost thaws and glaciers retreat. We can see other processes, and sometimes it's too simple when we will be here in the media or in some also from some members of the scientific community.
Absolutely. So Antarctica is super important. You've done a bit of work there. But heading to the other end of the planet, 24% of the world is covered in permafrost. A lot of that is in the Arctic. Tell us a little bit about the permafrost up in the Arctic.
Well, the permafrost community, I would say that it's mostly concerned about the development of permafrost in the Arctic, because here the permafrost contains large amounts of organic matter, and if temperatures continue to rise, then this Arctic layer, this layer that heavy summer goes and heavy winter freezes, then this layer can release all these greenhouse gases that are stored in this layer. And this can accelerate this greenhouse gas effect and world. And this is happening also in an accelerated way, and this is also leading several problems or changes in these regions. For example, changes in local ecosystems. So what we are saying is that the landscape is changing dramatically with the formation of lakes, wetlands, and this affects the vegetation cover, the plant species, but also the behavior of the fauna in these areas. Coastal erosion, for example, in the Arctic, it's a big problem. We have less sea ice, so this sea ice it's not protecting the coast, and this coast where we have permafrost, when it's exposed to the waves, then this coast starts being eroded, and then this is also affecting the local communities. But also we have problems regarding the hydrology. So permafrost conditions all the hydrological processes. Permafrost it's like a frozen layer, so that the water cannot penetrate in it. And if we have changes in this permafrost in state and the thickness of this permafrost, the hydrology, the runoff will be also affected. But in these areas, especially in the Arctic, Siberia, Canada, Alaska, we have roads, we have trains, we have cities, we have infrastructures that were built in a stable permafrost terrain. Once the permafrost starts going, all these infrastructure equipment can just collapse. So this is a big challenge, understanding what is happening in the Arctic, and also trying to prevent the future changes that for sure we will see in these areas.
Yeah, it's one of the things that's about the climate crisis that's always quite evident, that whenever things happen, it's normally things that happen to humans that we're really worried about. So changes in infrastructure, changes in weather patterns, those kind of things that we're really worried about. So there's changes in permafrost. What are the big things that are driving that? Is it local air temperature? Is it things that happen in the oceans, or is it just a mix of all of those things combined?
Yeah, I would say that it's a mix of these things combined. Especially, of course, it's temperatures. So it's the warming temperatures. As temperatures increase, and again, one of the areas where the temperature has increased more over the last decades, the Arctic. It has increased by a factor of 4. The top of the 4 times the global average. So as temperatures increase, these frozen layers, especially the uppermost part of these frozen layer, starts thawing. But at the same time, as we have higher temperatures, we also have more precipitation. We are seeing an increase of precipitation in these areas, and also in the form of snow. So we are seeing more snowfall in these areas. We have more snow, but this snow tends to melt earlier because we have higher temperatures. And as we have higher temperatures and this snow melts before, we have a growing period for the vegetables, for the vegetation to make the full cycle. So we have also longer ice freezes, and we are seeing a vegetation shift in these permafrost communities we are seeing that the trees are going up, migrating to the north. And at the same time, we are seeing a densification of the vegetation cover. And this also affects the permafrost. So again, it's not so straightforward to say that the temperatures increase and the permafrost is being affected. There are also some other local factors that are counterbalancing these dynamics.
Yeah, that Arctic amplification that you mentioned, that we talk about how many degrees the Earth is warming over the years. We're trying to hold it down to it's 1.2, 1.3 at the moment. We're trying to hold it at 1.5. We forget that in the most remote and most sensitive regions, that's already, in the Alps it's up to 2. In the Arctic now it's amplified up to 4. So it does seem like a bit of a cruel trick of the planet that the most sensitive regions are getting the most changes quickest.
I think it is true that it is like us. So it is clear that in the Arctic things are changing and changing really fast. In Antarctica, it is not that clear. Even because in Antarctica, so only the coastal regions are close to the 0 degrees temperature. So the 0 degrees, the change from +1 to -1, or -1 to +1 is a big change. In the interior of Antarctica, this is not a dramatic change because you are at -30, -50 degrees. So one less, 1 degree less or more, it's not a big change. But in the case of the coastal areas of the Maritime Antarctica, this can also be a big challenge. And of course, in mountain areas, we are seeing some mountain areas. We are also seeing a faster warming rate than that in the lowlands. So this is also another thing that is concerning the scientific community.
So this is something that, you know, as the outdoor community is getting more and more, is seeing more and more of those changes as permafrost starts to melt, as rockfall starts to become more of a thing in the mountain regions. How is permafrost different in the mountain regions compared to places like the Arctic?
Yes, so in the polar regions, basically permafrost is almost everywhere. Also in the lowlands, but in the mid and low latitude regions, such as where we are in Europe, permafrost is only found at a very high altitude. In the Pyrenees, in the Alps, at around 3,000 meters, we are starting to see the permafrost. And the one thing is that we have little infrastructure, so there's not so much population living or working in these areas. So the changes that we are seeing in the permafrost don't have the same socioeconomic implications than in the case of the Arctic. That permafrost in these regions is found in very steep areas, and where the solid rock keeps the building, the mountain building, just stay. But the problem is that when this solid rock becomes unstable because the permafrost is dying, then what may happen is that this permafrost, that is like the concrete that fixes the different rock ridges, then when it thaws, then all the rock wall can fall down and affect the mountain sides or ski facilities, or even the people that are visiting, that are trekking across the area. This is something that we know, for example, in the Mont Blanc Massif. So there is some hot areas during the year. Also some roads, some tracks that are closed or are. So the local guides try to avoid these areas during these heat waves in summer.
Yeah, I've seen it myself, and I've got friends who, again, will take choices based on now, you know, where the highest incident of rockfall is going to be, because the permafrost is not in a stable way compared to what it used to be. And you know, you talk about the places like the Pyrenees and the Alps at 3,000 meters and above will have this permafrost in a changing state. What about places then across the world that have higher mountain regions like the Himalaya and the Andes? Are they seeing also permafrost from 3,000 meters up, and how are they changing?
Well, basically, in the depends. So in Himalayas, permafrost is a little bit higher because the Himalayas are 25-30 degrees north. So you start having the permafrost depending on the local conditions. Even in the Andes, and in the area of the Andes, in the southern part of the Andes, Kerala, always at 1,000 meters. But if you go to the tropical areas, then the permafrost is almost 6,000 meters. In all areas, there was a study that was published years ago, where we did kind of a global survey of permafrost temperatures, how permafrost is behaving at the global scale. So we put together for the very first time all the data from the boreholes. So the other thing is, how do we study permafrost? So one of the ways to study permafrost is to make boreholes, to drill an borehole and put the thermometers inside. And then every year you go there and you collect the data and you see how the temperatures of the permafrost behave, if they are increasing or if they are decreasing. And when we did this study, we saw that in most of the areas, in the tropics, in the mid-latitude regions, in the polar regions, in the mountains, the trend of the warming permafrost is very clear in most of the areas. We need more data because this was just a study of 10 years. We need another series of data, but the trend was pretty much clear.
We were just talking offline about how difficult setting up those processes can be, about getting just the infrastructure of putting those boreholes in and things like that. You've got a new project in the Pyrenees, because I've seen a lot of changes over the years with glaciers and permafrost as well. The Perma Pyrenees project, how is that working out? What's it going to be doing into the future?
Yes, we had started this new project together with the Kenyan Journal Foundation. So they are responsible for all the communication simulation activities that we do. And basically, the main challenge of studying permafrost is that you don't see it. So it's not visible. There are people with permafrost that have not seen the permafrost in all their lives, because the permafrost definition refers to the thermal state of the permafrost. Everything which is frozen for at least through the years can be defined as permafrost. The rock, the sediments, soil, mammoth, whatever you find in the permafrost. So studying something which is not visible or cannot be visible, then it's challenging. And for this year, we are starting the project this year, and the project we last for 3 years. What we expect is to try to determine which are the best places where to study the permafrost, and we will do some geophysical surveys to know about the thermal properties of the ground in some areas where, even if we don't see the permafrost is in the landscape some features that are indicative of the presence of this permafrost.
Oh.
So, for example, rock glaciers. I'm not saying glaciers, but I'm saying rock glaciers. These are like tons of debris that move and create downflow in the mountains. In the Pyrenees, we have plenty of them. In the glacial series, which are now deglaciated, we have these ice, these tons of debris in the interior of these depressions, and we can be sure that these landfalls form under a permafrost regime. What we don't know is this permafrost is still present today, or if it disappeared because the warming temperatures led to the thawing of the permafrost. But in any case, these features are there, so they must have formed under permafrost regime. And we know that in some areas there is permafrost in the interior of these landforms, and we will go to these areas and we will do the geophysical survey. Then, based on the data, we will say, okay, in this point, we will drill a borehole and install detectors design, so that every year we will go there and see what is happening with this permafrost. And at the same time, we'll also put some several others across the rock walls to see what is happening with this with the temperatures in the rock walls. Because what we are seeing in the Pyrenees is the same process in the Alps. That this permafrost is degrading, so we have plenty of rockfalls that also, unfortunately, they have killed people in the highest areas. And for example, if you want to climb the highest mountain in the Pyrenees, now there's the Spanish wildlife the police, who is making some reports and advising not to go through the traditional way, because the problem is that the regional authorities, the local authorities, have not implemented any measures for that. So what we will try to do is to provide some guidelines for better management of the people in these permafrost areas.
I like the relationship between the scientists and the outdoor community and the politicians when it comes to things like that. That I don't think people realize sometimes how much effort science is. When teaching science, I used to say to kids, like, science is really fun. I've kind of stopped saying that because I think I'm old and jaded now. But also, like, if you want to do really good science, it's almost always really laborious, very time consuming, quite frustrating at times, trying to get permits for things and trying to make things happen, working with councils and governments and all this stuff. It can be really difficult, but it's always worth doing, right?
I mean, it is the first project in which is that I coordinate as a principal investigator that is more applied. Also, usually the previous project that they had were more theoretical, or something that the society do not see the outcome, the results. But in this case, and as I said, that we are starting the project now, it's as I said, it's starting to be frustrating. Some of the process for hiring people, for contracts, big public contracts, and it's kind of disgusting how it works. I think that you should ask me the same question in 3 years if I'm still alive after all these projects, and I will be able to respond properly.
And that's in the outdoor community, we talk about type 2 fun, where you look backwards after a big race or a hike or something, and it hurt at the time, but it was always worth doing. Those memories that you've created, the challenge itself was always worth it. And I feel like it's the same with science. Like, even if you come out with a paper that isn't the results you were expecting, it was still worth doing because you found what it's not. And with projects like this, where you're going to find like specific data that can help shape our thinking of permafrost in the Pyrenees going forward, that's going to be so worth it looking back and finding this project, 3 years on. So you've got this Perma Pyrenees project. You've studied in the Arctic and the Antarctic. What is going forward, findings from your research? What are we finding? What are some impactful findings that you've found on your research that we can think about in terms of permafrost?
Well, we have just seen recently the final disappearance of permafrost in the Sierra Nevada, for example, in South Spain. We are seeing that permafrost in the Pyrenees appears to be more extensive than they initially thought. And we are seeing also that in Antarctica, for example, permafrost forms after the glaciers retreat. Also, it's that permafrost dynamics is really a complex issue. It's what we said before, that it's not as simple as we think. The temperatures rise and permafrost degrades. With higher temperatures, we have also several feedback in terms of snow, or the type of vegetation, the timing of the vegetation, the development of the vegetation cover. So we need also to integrate and to improve our models to better understand how permafrost could evolve in a warming climate.
Wow. And are there any big questions about permafrost that the permafrost scientists are still trying to answer? There's always things that we didn't know, and some of the best questions in science are ones that we haven't even come up with yet. Are there any kind of surprising findings that you guys are finding, or what's the big questions that you're still trying to answer?
Yes, well, I would say that one of the big questions that it's now being addressed with the permafrost community is about the biogeochemical cycle in permafrost regions, and particularly most of the focus is in the Arctic. And this is also the case as permafrost temperatures rise and the cold layer thickness in summer. There are several chemical and biological processes, and this is accelerating because of the greenhouse gases stored in the Arctic. But how much permafrost is there in the Arctic? Where is it? This permafrost, and which there? What are the processes since the permafrost thaws and then it's being released again into the atmosphere? Or what is the connection between the land and the oceans? What is the role of the rivers, of the lakes? And there are many questions that are still not answered and are not properly known. And this is one of the big challenges for the scientific community. We are not working on that, but of course we are part of the community, and we work with other companies that are complementary to this major issue for the permafrost.
It's one of my favorite things, I think, about science is that the more questions we answer, it seems that the more questions we have. That there's always new things that we don't know, and that's the fascinating thing.
It is for sure. When you think you try to close the door, then you see it again, and you say, "Oh, I will have to reopen it because there's something that it's still unknown." It is.
It's one of the safest jobs in the world, being a scientist. There's always going to be more questions to answer. Marc, thank you so much for being on the Athlete Climate Academy podcast. It's been an absolute pleasure.
Okay, thank you very much.